Okay, so this is my circuit design for EE20 project. A 12-hour digital clock display with weekday. It's 12 hours with a PM AM toggle. And basically what I have here is just seconds and minutes using the same circuits, and the counter input for the minutes comes from the output of the second 10 seconds counter, and then the output from the minutes gets fed to the tens as a counter, and then this counter, same thing with the hours to the toggle, from the toggle to the weekday counter, and then from the weekday counter through its encoder to these LEDs. So right now the circuit is set to clear, and the clocks aren't ticking right now. It's not counting right now. But once I enable it, it'll start to count. You can see I have it set to a really high frequency, so you can see the changes in all of them. So once it's 5, it'll change from 1, as you saw the PM AM toggled as well. So now let me show a little more. Of the circuits. So these are some of the chips I had to create. This 0 to 9 counter, which uses 4 JK flip-flops to produce 4 bits. And then I have these AND gates in sequence, and basically when all of them are 0, this equals 1, and it passes on. As you can see, it's green. The output is a 1, which acts as the counter for the 0 to 5 counter, which I have here. And then this is a 0 to 5 counter from 3 bits. Again, I'm using 3 JK flip-flops. The way I got these circuits is through truth tables, and finding the values through with the Carnot map. And then this is the basic 0 to 9 counter for 7 segment display using 4 bits. And then this is a special one for using 4 bits for counting from 12 to 1 all the way up to 11, and then restarting. So 12, this is the input for 12, 0, 0, 0, 0. And then this is a 1 through 12 counter to go along with that display driver. Yeah, it pretty much counts from 0, 0 to 1, 0, 1, 1, where 12 is 0, 0, 0, and 11 is 1, 0, 1, 1. Okay, and then this is a AM PM toggle. It's basically a JK flip-flop with a constant 1, which is the same as a toggle flip-flop. And this is the weekday counter, which is a lot like the 0 to 5 counter, except that it uses some OR gates for the inputs of J and K for A and B. And then I had to create this encoder because the encoders on Logicsim wouldn't work for me. And then just to go over, just to show that everything here works, I'm just simulate it again. I'm enable the clock now. at a really high frequency. Okay, now let me lower the frequency to regular 1 hertz. You'll see right here, looks like a regular second or clock. 0, 5, and then same with this as well. But just to show that this part right here also works, I'm just going to disable the clocks for now, and then manually punch in a value myself using a button. So just place a button right here, and then disconnect this for a second. And every time I press the button, it'll toggle the weekday counter. Oh, I gotta enable it. So enable the weekday counter. And you'll see it goes through the days: Thursday, Fridays, Saturday, and then even though it has this extra output down there, it's not being used. If I click the button, it'll still go back to Sunday. That's basically how this works. But yeah, let me disconnect this. Oh. Okay, now I'm gonna add this to the AM PM toggle so you can see how this works. Well, then if you look here, every time I click the button, switches, every 2 switches, every time it goes back to AM, switches the day. So it's on Wednesday now, Thursday, Friday, Saturday, Sunday. Let me disconnect this. And then I could do the same for the 12-hour counter and show that. And also do the same for those to show these. But yeah, that's my circuit and my project.